Hello students, welcome back to another video. The question which we have taken up today is a question from this year's sample paper. And the question reads, the above circuit is a part of an electrical device. Use the information given in the question to calculate the following. Potential difference across R2, the value of resistance R2 and the value of resistance R1. So let's have a look at the circuit diagram first. So here we have a circuit diagram in which there are a few resistors which are connected, and we see here that these two resistors, this 4 ohm and R2, are connected in parallel with each other, and R1 and this 2 ohm resistor is connected in series with this one. So now we have to find out the potential difference across R2 as the first question. So let's solve it. So now let's consider these 2 points, say X and Y. Now at the point X, the wires are branching into 2 parts. One is connected to the 4 ohm resistor and another to the resistor R2. So the potential difference at the point X and Y are the same. So now what will be the potential difference across this 4 ohm resistor? The same potential difference will be across the resistor R2. So let's find out the potential difference across the 4 ohm resistor. Now for the 4 ohm resistor, the resistance given here is R is equal to 4 ohm and the current given is 1.5 ampere. So the potential difference we can find out using Ohm's law, that is V is equal to IR. So I is given 1.5 and resistance is 4 ohm. So the potential difference is 6 volt. So the potential difference across the resistor R2 is 6 volt. Because what will be the potential difference across the 4 ohm resistor? Since it is connected in parallel with resistor R2, so these two will be working at the same potential difference. So the value of the potential difference across R2 is 6 volt. So this is the first bit. The second bit question is the value of resistance R2. Alright. So now we know that the potential difference across the R2 resistor is 6 volt. Now you can see the current near the resistor R1 is 2 ampere. That means 2 ampere current is coming to this branch. Okay. So a current of 2 ampere is coming to this part, that is the part X. Now from X, the current is dividing into 2 branches or 2 parts. From this 2 ampere current, 1.5 ampere current is going through the resistor 4 ohm. As you can see, it is mentioned over here that a current of 1.5 ampere is flowing through the 4 ohm resistor. So if 1.5 ampere of the 2 ampere current is going to the 4 ohm resistor, the remaining current will pass through the resistor R2. That is, the current over here that is passing through the resistor R2 is 0.5 ampere. Alright. So how can we write this? That is, the current through the resistor R2 is the total current minus current through the 4 ohm resistor. So the total current here is 2 ampere minus the amount of current passing through the resistor 4 ohm is 1.5 ampere. Hence the current through the resistance R2 is 0.5 ampere. So the current through the resistor R2 is 0.5. Let's find out what will be the value of this resistance R2. Now we know the voltage or the potential difference is 6 volt and the current passing through the resistor R2 is 0.5 ampere. So the value of resistance R is V by I from Ohm's law. So potential difference is 6 volt by 0.5 ampere. So that comes to be 60 by 5, that is 12 ohm. So the resistance R2 is 12 ohm. So this is the answer to the second bit. Now let's solve the third bit question. So in the third bit, we have to find out the value of resistance R1. So in order to find out the value of the resistance, we need to find out the potential difference and the current. Now the current through the resistance R1 is given as 2 ampere. So we need to find out the potential difference across R1 and then we can apply Ohm's law and find out. So let's write down the current given through R1 is 2 ampere. So let's find out the potential difference. Now potential difference across R1 will be the total potential difference, that is the potential difference given over here, minus the potential difference across this part, that is the part x and y, that is we can write, say, let it be R2. So it's the potential difference across R2 minus the potential difference across this resistor 2 ohm, across the 2 ohm resistor. Now the potential difference across the resistor R2 we got here as 6 volt. So this is 6 volt. And the potential difference across the 2 ohm resistor is, from Ohm's law, V is equal to IR. That is, the current given here is 2 ampere and the resistance given here is 2 ohm. So the potential difference across the 2 ohm resistor is 4 volt. So here we got potential difference across the 2 ohm resistor is 4 volt. Now if we apply these values, this VR2 and V2 ohm, in this equation we get the potential difference across the R1 resistor is 12 volt, that is the total potential difference of the circuit, minus the potential difference across the resistor R2, that is 6 volt, plus the potential difference across the 2 ohm resistor, that is 4 volt. So here we get, so it is 12 minus 10, that is 2 volt. So the potential difference across resistor R1 is 2 volt. Now that we have the potential difference, let's find out the value of this resistor. So let me write it here. From Ohm's law, V is equal to IR. So here we have to find out R1. R1 is V R1 by I across the resistance R1. The potential difference across the resistance R1 is 2 volt, which we got just now, and the current given over here is 2 ampere. So the resistance R1 is 1 ohm. So this is the value of the resistance R1. That is, the value of resistance R1 is 1 ohm. So this is the final answer. So I hope you have understood the solution to this question. If this video was helpful to you, please like this video, share it with your friends and subscribe to the channel. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.